Hello and welcome. In this video, we're going to be looking at a somewhat tough and actually very tough question from the October-November 16 Cambridge Mechanics exam, variant 3. So let's start by reading the question. It says that a ball A is released from rest at the top of a tower. 1 second later, another ball B is projected vertically upwards from ground level near bottom of the tower with a speed of 20 meters per second. The two balls are at the same height 1.5 seconds after ball B is projected. Show that the height of the tower is 50 meters. In those questions, what you should do is not always think about this or what's the question or what does the question want. No. What you need to do is to understand what's happening, okay? And this is what we are going to do here. First of all, this is very directly a kinematics question. So let's start by taking one object at a time. First, let's see ball A. It says that ball A is released from rest at the top of a tall tower. So let's say this is a tower. Here, this is ground. So let's okay, so we're talking about ball A over here. So ball A is released from rest, so U is 0 meters per second, and ball A is gonna start to move downwards. And then we have another ball, that is ball B. It's projected upwards with a speed of 20 meters per second, so U equals 20 meters per second. However, they were not projected at the same exact moment. What happened is that A is released, and then after that, B is released after A by 1 second. So, show that the height of the tower is 50 meters, and it told us that the two balls are at the same height 1.5 seconds after ball B is projected. So let's see, after 1.5 seconds after ball B is projected, how much did B move? But first, I'll need to know, did B move up and then reached its maximum and then started moving down, okay, during the 1.5 second period, or what happened? So first, what I will do is I will come here and I will do the quantities for B taking upwards as positive. What I'm trying to find is where is the time it took for B to reach its maximum height or a velocity of 0 and then to start moving down again. This is what I want to know in the beginning. So what I will say that U is going to be 20 meters per second. It's going to be positive because we took positive as upwards. And V is going to be 0. I know the acceleration, since acceleration of gravity is downwards, it's going to be negative value. It has a value of 10 meters per second squared. And I want to know what time took for B to do all that. So over here, I can see that I mentioned U, V, A, and T. I did not mention S, so I will use the equation which doesn't have an S, which goes like this. V equals U plus A T. So V is 0, U is 20, plus A is negative 10, and T is the thing that I want to know. So if I move this negative T to the other side, becomes 10T equals 20, divide 10, so T equals 2 seconds. So B will take 2 seconds to reach its maximum height. That means that the 1.5 second period where both of them were together, so this is A dash, let's say, and this is B dash, okay? This happened while B was moving upwards. It didn't happen when B moved to its maximum height and then it was going down. That's very, very important to know. So now we know that B took just 2 seconds to reach its maximum height. So when they both were at the same level, B was still moving upwards and A was moving downwards. And this happened 1.5 seconds after B was released. Okay, so now to find the height, let's see the actual distance or displacement B is after 1.5 seconds. So over here, what we can do is we can come and erase this. We don't need it. Actually, let's leave it. It's important for later. What we need to know is we need to know what is the displacement for B after 1.5 seconds. So what we can do is we can come here again, do another one for B, taking up as positive. U is 20 meters per second. Acceleration is negative 10 meters per second squared. Time is 1.5 seconds, and I want to find what is my S. So the value I didn't mention here is V, so I'm going to use the equation that doesn't include a V, which is S equals UT plus half AT squared. So S is going to equal U, which is 20, times time, which is 1.5, plus half times acceleration, which is negative 10, times time, which is 1.5 squared. And this should give me an answer of negative 10 times 18.75 meters. So over here, it took 1.5 seconds and 18.75 meters from the bottom. Okay, now let's see the distance that A moved from the top up to here, and then when we combine this distance plus that distance x, it will give us the distance of the whole tower. So let's start doing that. So now let's think about ball A. First of all, A was released, okay, sorry, B was released 1 second after A. So the question tells me that the balls are at the same height 1.5 seconds after B is projected. So A was projected, so A was moving down, and then let's say A reached over here after 1 second, and when A reached over here, B was reached, and then it took one extra 1.5 seconds for them to be at the same level. So how much time has passed for A for them to be at the same position? You guessed 1, the original second before B was projected, and then the 1.5 seconds until they both became at the same height. So for A, 2.5 seconds has passed. You need to take care of this. These are a little bit confusing because of you need to take care which one was launched first and so on. So in this position, A has 2.5 seconds passing. Okay, so the time for A to reach this position was 2.5. It was not 1.5 just like B. So let's do everything for A now. And actually, I'm going to take downwards as positive because it's more convenient here. So I know that my U is 0 meters per second. My acceleration is going to be 10 meters per second squared. Why positive? Because down is positive, and I know that acceleration to gravity is downwards. Time is going to be 2.5 seconds, and I want to know the displacement it took for A to move in 2.5 seconds. So which value or which quantity, which letter didn't I mention? It was V, so I'm going to use the equation which doesn't include a V, which goes like this. So S is going to equal U times T. 0 times T is basically 0, plus half times A, which is 10, times T, which is 2.5, T squared, so 2.5 squared. So this is going to give me an answer of 31.25 meters. So this x is 31.25 meters. If we get the total height, is going to equal the 31.25 plus the 18.75, and this is going to equal 50 meters, and this is what we were supposed to show in part A. So now this is part A done. Let's clean up a little bit. Let's remove this part, and let's remove this part as well. We don't need it. Okay, so now we know that the whole tower is 50 meters in length. So we can erase all this and then say that the whole tower is 50 meters. Okay, now part 2 tells me find the length of time for which ball B has been in motion when ball A reaches the ground. Okay, so now what I'll need to do is I'll need to find the time, okay, where ball B is in motion, okay, until ball A reaches the ground. So let's do the scenario again. What happened was A was released, A is moving down, and then after 1 second, let's say A at t equals 1 second. A is here. Now, after 1 second has passed for A, B started to move. Okay, so B started to move 1 second later than A. Now, the question tells me, until A reaches the floor, what's the total amount of time that B was in motion? Okay, so first of all, it's very useful for me to find the time it took for A to reach from the top of the tower to the ground. So what I can do is I can say, again, the things for A, taking down as positive, take U as 0. My distance or my displacement is going to be positive 50. Why positive? Because 50 meters below the starting point, and we're saying that anything that's down or below is going to be positive. We know that we need the time, and we have the acceleration as 10 meters per second squared. So which letter didn't I mention over here? Again, letter V, so I'm going to use S equals ut plus half at squared to find the time. So S, which is 50, equals u times t, so 0, plus half times 10 times t squared. So over here, half times 10 is basically 5. Okay, and then I'm going to do divide 5 both sides. So 10 equals t squared. So t equals square root of 10, and this is going to give me a value of 3.162 seconds. So this is the total time that A took from the moment it was released until it reached the ground. So in that period of time, how long was B in motion? We know that B was released 1 second after A, right? So basically, 1 second after A was released, B is now moving. Now, after 1 second, A has 3.162 minus 1 second, so it has 2.162 seconds in order to reach the ground. And that is when B was released. So it means that B took 3.162 minus 3.162 minus 1 second. So B was in motion 2.162 seconds, okay, until A reached the ground. But you will tell me how. A took 3.162 seconds to reach. I'll tell you yes, but the first second of motion of A, B was not moving. B only started moving 1 second after A started moving. So A had 2.162 seconds left to reach the ground, and that is where at the time where they are both in motion. So this is the first part. The second part tells me, hence find the total distance traveled by B up to the instant when ball A reaches the ground. So let's say this is 1 second, okay? B here started moving. So we want to see the total distance traveled by B up to the instant when ball A reaches the ground. So we know that B is going to move for 2.162 seconds until A reaches the ground, right? So if we come here and we say, if I put my time as 2.162 seconds and I start solving for the displacement for B, this is going to give me an inaccurate answer. Why? Because remember, in the first thing that we did, we said, I want to know what time has passed for B until it reached its maximum height. And this time was 2 seconds. So B was in motion for 2.162 seconds, and the first 2 seconds of this period, B was moving up, and then the rest, which is 0.162 seconds, B was moving down. So I need to take that into account. And let's see how can we do that. So first, let me actually find the distance, or the distance B took in order to reach its maximum height. So we can come here again. For B, U is 20, V is 0, because I'm trying to see where B reached its maximum height, so where it stopped moving upwards and it's going to move downwards now. A is negative 10, T we got it as 2, we want to now take displacement. What is the displacement? How much did B move? Again, I can use any of the Saviot equations over here. However, I will choose the one that doesn't have a time in it. Why? Because time is something I was calculated. So I might have done it wrong. So I don't want that to use it in my displacement to get also the displacement wrong. This is something you can take care of while you can, not always. This is not always applicable. So the equation that does not include time is which equation? It's v squared equals u squared plus 2as. Okay, so v squared is 0 equals u squared is 20 squared plus 2 multiply negative 10 multiply s. So over here, 2 times negative 10 is 20. Move that to the other side, becomes 20s equals 20 squared. I can divide 20 by 120 here, so s equals 20 meters. So the displacement until B reaches its maximum height was 20 meters. And that took 2 seconds, okay? After 2 seconds, did A reach the ground? No, A still has 2.162 minus 2 seconds, so it still has a time of 0.162 seconds in motion until it reaches the ground. So I'll need to see how much distance did B move in that time. So let's do that. So after 2.162 seconds, where is B? So let's try and do that. Again, we will come here. Let's erase this. So the initial distance was 20. We can now erase this. We know that. Let me come here for B and erase values. Now, I want to know when. Now, I don't have my V. Okay. Now, I want to know when time that passed for B is 2.162 seconds. 2.162 seconds. That is when A hit the ground. Where is B? What's the displacement of B? So now what I'm going to do is I'm going to do the equation which doesn't include a V. So I'm going to use S equals UT plus half AT squared. So S is going to equal U, which is 20, multiply T, which is 2.162, plus half times acceleration, which is negative 10, times time squared, which is 2.162 all squared. If I plug that into the calculator, it will give me 19.869 meters. That means that after 2.162 seconds, B is now over here. It moved down a little bit, so I'd expect my displacement to be actually a little bit lower, which is the case, 9.869 meters. So the question asks for the total distance. It means that the distance that B moved upwards, which was 20, plus this distance which B moved in this 0.162 seconds window until A reached the ground. So what's this distance that B moved? What's this distance? It's basically the difference between 20 and the 19.869. So if we do 20 minus 19.869, that's going to give me an answer of 0.131 meter. So this is the extra distance that B moved downwards. So the total distance is going to be the distance that B moved upwards, which is 20 meters, plus the extra distance that B moved downwards, is 0.131 meter. If we add them, it's going to give me 20.131 meter. Or did the question specify for any? No. So 3 significant figures is enough. So 20.1 meters is the distance that B moved until A reached the ground. So I hope this video was helpful and I hope was insightful. These questions are always difficult and confusing. However, when you split everything into sections and logically think each section what is happening, it will become a lot easier, and this is the way I always solve it. Anyways, if you like this video, please don't forget to subscribe, comment down below, leave a like, and ask any questions if you'd like. Hope you benefited from this video. Thanks for watching and have a nice day.